Greetings once again, friends. My name is John Gabriel, and this is a new calculus channel. In this video, I will reveal how Euclid, that's right, Euclid, missed some very simple proofs that follow directly from the 5 requirements. To do this, I use Book 1 and Proposition 4, which is the first proposition that reduces to the absurd. Okay, so let's see, why does that proposition reduce to the absurd? Well, it says the very thing is impossible because it assumes that 2 straight lines will encompass an area. Okay, and of course what Thomas Heath wrote down here in this commentary is absolute rubbish. He says that Euclid implicitly assumes that the straight line joining 2 given points is unique. It most definitely is unique because the only unique path between any 2 given points is a straight line. So I suppose Sir Thomas Heath must have been drinking something when he wrote that. But anyway, let's put that aside and see what Proposition 4 says. So this is what Proposition 4 says. It says, if 2 triangles, this triangle ABC and DEF, have 2 sides equal to 2 sides, so the green side equal to the green side, the red side equal to the red side, and have angles enclosed by the equal straight lines equal, in other words, this angle equal to this angle, right? Then they will also have the base, which is the blue line, the base equal to the base. So this line will obviously equal to this line, right? Now, you know, I honestly don't know why Euclid went to such lengths, because he obviously missed the point that this could have been done very easily using the circle, and I'll show you how. So, we know that we can take any one of these 2 lines, and in this case I've just chosen the red one and let it be the diameter of a circle, okay? So you could take either the green or the red line and let it be a diameter of the circle. Then you could put both of these triangles, which have corresponding vertices AD here, CF there, and BE there, and you know that the green and the red are equal. Now you're wondering whether the blue will be equal. Well, let's examine this. Okay, so now if they were not equal, right? This is my proof now, not Euclid's proof. If they were not equal, then this angle here, which they have in common, would be subtended on a longer arc, okay? In other words, if this line, let's say that EF was longer than BC, so let's say that EF is this line here from the red dot to the green dot, then we would have a much larger arc. And we know that equal arcs subtend the same angle, or the same angle is subtended on equal arcs. And how do we know that? Because remember, the definition of parallel is derived from that very thing. So if we had to draw a line through these 2 blue points, it would be parallel to the diameter because these arcs are equal. And how do we know that the arcs are equal? Because the circle is symmetrical about a diameter. Okay, the circle is symmetrical about a diameter. And we also show in my fine article, which I will post a link to, that there are no axioms or postulates in sound mathematics, and that all these 5 requirements of Euclid's are derived systematically from nothing. And you can read that. It's quite a long presentation, but it will require you to think about it carefully and study it. So obviously that wouldn't work, right? So the blue line, this EF couldn't be longer than BC, and if it was shorter, then this angle here, this little angle here is subtended on a different arc, so it can't be equal to this other angle. So it can't be short. It can be shorter and it can't be longer. Therefore, what does that mean? It means that BC must be equal to EF, right? And that's all there is to it. And now this other line here according to the proof that Euclid uses, he shows that if it's anywhere here or here, then there's an area between the two lines. And according to the definition here, he says, thus the base BC will coincide with EF and it will be equal to it. So the whole triangle will coincide. And it says, I'm sorry, that's not it. For if B coincides with E and C with F, then the base BC does not coincide with EF. And then the two straight lines will encompass an area. So, and he says that very thing is impossible. The two straight lines cannot encompass an area, okay, because they're part of the same triangle, okay? So this way or this way would result in an absurdity. So it has to be equal, okay? So there's no way that if you had this, these things given, these green lines equal, the red lines equal, and the angle between them equal, that this line here would not be equal to this line. It would, okay? And the way to prove it is to use a circle, because we've already derived a circle from the 5 requirements. So that's pretty much it for now. I will continue to look at these things in more detail and show you how to understand the important elements of Euclid so that you can understand the foundations of mathematics. I'm John Gabriel. This is New Calculus Channel. Till next time, goodbye.